now for some expansion, what we'll do is we will see how we can expand these into as many as possible. So let's take a couple steps here. We got a log, base 2, and we're going to go ahead and put the 4x minus 5, but we're going to raise it to the 1/3 now. Then we're going to put the 1/3 in front, because that's what you can do. All right, and then that would be 4x minus 5. Can you go any further than that? The answer is no. That's it. That's the end of the row. This is subtraction on the inside. The subtraction on the inside, you can't do anything. It's only when you've got multiplication or when you have subtraction addition on the outside of the logs. When they're on the inside, there's nothing to expand. Okay, so this one right here, we've got these two. We've got these three being multiplied to each other. A 7 is coming to the front, and then we're going to be dividing by this guy. So it looks like we're going to have a log base 4 of 3 plus 7 log base 4 of A plus log base 4 of C minus the log base 4 of 5. Okay, now the reason why you would want to ever expand these is that you can actually figure out what each of these individual ones are. As a group, you can't actually do that. But there might be a situation where, maybe 3 of these are actually just numbers. And so you can kind of figure those out quickly. All right, maybe you know what A is, and then you can figure out what that is quickly. And you definitely know this one, and you can enter that in the calculator. And maybe you just need to solve for C. Okay, so sometimes that's beneficial. It doesn't show up too much here in this class. But we do use logs quite a bit in calculus. They show up quite a bit. All right, so now we're going to go ahead. We're going to distribute that. Well, there's a couple ways we can do this. What I'm going to do is just put the 3 in front like this. Okay. And he can actually maintain, he'll just be on the outside of the parentheses of all of these guys. So I've got 1, 2, 3. So 3 parentheses log of 5. Okay, our base is 10, so we've also then got plus 1/2 the log of u. Now, sometimes also, too, by the way, sometimes that looks like this, like that. Okay, instead of putting the half in front, I like the half in front, but sometimes you'll just see this on certain tests. They'll put it over 2 like this. And then we're going to minus 2 log of w. Okay, now that 3 is because all of them are being raised. Now we could distribute that 3 to all of them, but it's either way, it depends on what you consider kind of expansion, Okay, now this right here, what I'm looking for here is I do see that this is actually factorable. Otherwise, like, where else are you going to go? This guy is negative 24, negative 2. That would be negative 6 and positive 4. And so what we've got is 2 parentheses being multiplied to each other. So that would be x minus 3 divided by 3, x plus 4 divided by 3. So what we've got is we've got the ln of x minus 2 times 3x plus 4. Okay, so with that, we haven't expanded anything yet. All we did was factor it. In fact, I think it's better to do this because you don't want to be under the impression that this first parenthesis is actually the only one having the log done to it, or natural log. So if you put it in brackets, it's very clear that both of them are inside the natural log. But now we can actually separate this and say that plus. Okay, and that's all that you can do. That's as far as you can go. All right, let's solve a couple of these before I change the video. Okay, well, I see 2 logs equaling each other. That's great. So those guys are super nice because we could just say that this equals that. And we have to make sure that we are looking for negative numbers, because we can't have negative numbers on the inside of logs because you can't take the logs of negative numbers. So you get x squared plus 4x. This negative 12 is going to move over and he will just become 12, and that will then equal 0. The reason why I set it equal to 0 is because it's quadratic. Let's see if there are factors of negative 12 that add up to 4, and 3, and 6, and 2. So it looks like it's 6 and 2. So you got a positive 6 and a negative 2. X equals negative 6 and positive 2. But let's see, negative 6 here ends up being squared. So 36 and a big number. That big number is good. Squared. Okay, so actually the negative number works out well. We're good. 2 is good too. We're just going to get positive numbers. So that's it. That's our final answer. Here it looks like I'm going to have to condense these two and then cross out the log. So let's squeeze those guys together so that it is division because of the subtraction. And that's going to equal log base 9 of k plus 6. Okay, so now we can cross it out. And it doesn't matter what the log base is. Log base 9, it doesn't matter. The 9 is actually irrelevant. We have 9, k, one more time, 12 minus 12 divided by k minus 5 equals k plus 6. All right, so that's going to have to cross multiply here for a k squared plus 6k minus 5k minus 30 has to equal 12. So this comes up here. I'm going to add those two together for k squared plus k. Now it's going to actually equal a negative 42 equals 0. So it's, remember, quadratics, the only way to solve them is to dial them to 0. And if we factor this guy, it would be k plus 7 and k minus 6. So k equals negative 7 and 6. Now if this negative 7 produces a negative number anywhere, we have to cross it out, and I see it right there. If I plug in a negative 7 here, I would get log base n of negative 1. He is a no-go. He is extraneous, so k has to just equal 6. 6 isn't going to be a problem here, and it definitely won't be a problem there. Okay, so now, we got a square root. Okay, so this isn't actually going to be too big of a deal here. I'm going to put the square root right here at the top, like that. And I'm going to squeeze these together so that this guy is 6, because these two logs together will now equal 6 once I multiply those. So now they equal the same, cross, cross. And I get the square root of 5c minus 9 equals 6. So, square both sides. In fact, this is what Algebra 2 is working on right now. And we will get 36. 5c equals, let's see, add 9 to both sides, and we're going to get 45. So c equals 9. Is 9 going to be an issue here? Nope. Okay. And we are all set. All right, so now we do not have two opposing logs on either side. We only have one log. So that means we're going to have to do the loop in order to get this straight. So let's go ahead and move this guy over here. We can't undo the log until it is completely isolated on one side. And so we are going to subtract 2. So let's subtract 2 here. Now, I'm going to subtract I'm going to subtract 6 over 3, okay? And that's going to give me 5 over 3, okay? I just turned it into a fraction with the common denominator. So now I have a log base 8 of 7 minus 5w equaling 5 over 3, okay? Now, here's what you do when you have a log on one side. You do the loop. Okay, so 7 minus 5w. So you would raise 8 to the 5 over 3 power. Now, this is actually one of those where it would be nice if you could do that in your head, because you could take the third root of 8. It's actually 2. And the 2 to the 5th power is 32. But if you needed a calculator for that, it's okay. It's not the end of the world. We're going to move that 7 over here. 32 minus 7, I do not trust I'm going completely without a calculator today. This is 525. Okay, so now it looks like W is -5. And is that going to, nope, minus a -25 here would give us a positive number. So we are good, -5. All right, I'm going to do these last two. Okay, so now we've got a 1/2 can go on the inside here. That becomes 9 square root. The square root of 9, that's 3. So then that would be the ln of 3. Okay, now if I'm adding this ln and that ln, that means that I would actually multiply. So here I'm going to write out this step. 3 times 2r minus n has to equal 7. We've done nothing to the other side, but we are going to now, because we can undo the ln by doing the loop, just remembering that the ln has a base of e. So e to the 7th equals 3 times 2r minus 7. Okay, now e to the 7th is going to be just a decimal. It's going to be quite a large one, actually. So what I'm going to do actually is I'm just going to keep it e to the 7th, and then at the very end I'm going to figure out what that decimal is. Okay, so 6r minus 9. So now what we've got is r is going to equal e to the 7th. First has to be plus 9, and then you would get that decimal, and then you would divide by 6. Okay, so this in calculus, we would leave it like that. That is perfectly fine, but e to the 7th. Okay, let's see what that is. E to the 7th. My dog is drinking water like he's never had it before behind me. Is 184, etc., etc. Okay? So if you got this one, you're absolutely correct. It's just this is like the nice kind of like perfect, this like kind of encapsulates all the decimal places. Okay, again, we're going to have to move this 9 over here before we can do the loop, and we're going to get, oh, that's a 3 as well, so, you know what we'll do? How about we, instead of moving that 3 here, that is going to be a huge problem. We can divide this whole side by 3 as long as we do it to this side too. So let's subtract 9 first, okay, and then over here we would actually get, what is that, 6? Okay, now we'll divide by 3. So that's great, okay? So that is a lovely little shortcut there. So now we can just raise 2 to the 2nd power rather than 6 to the 6th power and then having to multiply him out to the 3. So it's nice. It all depends on this 3 here is helpful on the inside, but sometimes not. Sometimes it's better to put them on the outside so that you can just divide this exponent by it, and then it makes it for a much easier situation. This is 2h minus 6 minus 14h has to equal 36. Okay, so now we got another quadratic here. We're going to divide everything. Let's move him over here first, and then we'll divide everything by 2. And that's going to be 18. Okay, and then that'll be a 9 and a 2. So that would be h minus 9, and then h plus 2 equals 0. We got h equals 9 and negative 2. Let's double check. Oh, by the way, this r is super large, so we're no problem getting a negative. We're not going to get a negative number there. But over here, 9. Okay, this one I actually do have to check. 2. Let's see if I can brighten this up a little bit. Here we go. 2 times 9. No, that's not what I want to do. 2 times 9 to the 2nd power. Try that again. Okay, so that's a positive number. That's going to be okay. All right, and then negative 2. Negative 2 isn't going to be a problem at all because he'll become positive, he'll become positive. Okay, so these guys are good to go. All right.